This video dealing with the properties of an isosceles trapezoid. We're going to go ahead and once again look at the properties and then see if we can go ahead and apply them to some problems that we may see on our retake, we have seen on the actual exam. I'm going to go ahead and start down here with the properties of the diagonal and another additional property that we're going to go ahead and use in question 10b. Diagonals are in fact congruent. So one thing is that this entire diagonal is congruent to this entire diagonal. And we actually know also that the tops of these diagonals are above the intersection point and below the intersection point are congruent. So the two pieces above the intersection point are congruent and the two pieces below the intersection point are also congruent. This goes occasionally. The main property that really shows up is this idea of the mid-segment. We had talked about the idea of a mid-segment before. The formula to calculate the mid-segment is basically going to be the average of the bases. So we're going to add the top and bottom of our lengths of our isosceles trapezoid and then divide it by 2 to figure out halfway through. Let's go ahead and take a look over here at 11b. We are given a trapezoid, and we should note that this is in fact the mid-segment. So we have this piece being congruent to this piece and this piece being congruent to this piece. So if I want to go ahead and figure out what the value of x is, if I tell you that that is in fact the mid-segment, we know that the mid-segment is equal to base 1 plus base 2 divided by 2. Looking here, we can call this distance base 1, and we can call this distance base 2. So using my formula, we have 42 plus 36 divided by 2 is equal to whatever the length of the mid-segment is. In this case, the length is 5x minus 31. So to simplify this, we're going to go ahead and solve this. We're going to simplify this right hand, which ends up being a value of 39. So now we're going to go ahead and solve this two-step equation, giving us that x is equal to 14. There will definitely be one of these on our retake. Got to know the formula, got to know the idea behind this particular problem. We've seen it before. We're just finding the average of the bases and setting it equal to whatever that value is going to be. One small note is that if I actually think about it, 39, which was our mid-segment value, if we look at the two bases, 42 and 36, this is actually the middle number. We go down 3 units from 42, and we would go up 3 units from 36. So it is in fact the middle number in terms of the value. So we're finding the average happening there. Okay, properties of a isosceles trapezoid in terms of sides and angle measures. In order to be a trapezoid, there's exactly one pair of opposite sides that are parallel. We see here that we have the top and the bottom, the bases being in fact parallel. They're not congruent though. We only have non-parallel sides. So the two sides that are not parallel in an isosceles triangle are the only ones that are going to be congruent. I don't have a problem for this, but I'm going to go ahead and make one up. Let's say I called this side length A, the variable A, and I told you that this was equal to 15. Well, I know that this side is in fact congruent to this side. So we would be able to say that side length A is congruent to 15 as well. Okay, that may show up. That was actually on the test. Most people got this one right, but just to remind you of that property. The real property we're looking for here is the one that shows up, I think, on SOLs a lot, is that lower base angles are congruent and upper base angles are congruent. So this is a lower base angle, this gray angle I have, and this is a lower base angle. These in green would be my upper base angles, and they are also congruent. And all the other shapes we've had this idea of opposite angles being congruent. With an isosceles trapezoid, we have the two lower values and the two upper values, the angles, being congruent. So in our particular problem for 11A, what that means is this angle B is in fact congruent to angle C. So we can set up the relationship that 7y plus 2 is equal to 100. So we solve in this two-step equation, giving us that y is equal to 14. Now, we also know that angle A is congruent to angle D, but there's two variables here, so I'm going to hold off on setting up that relationship. Instead, we're going to look at the very last property, is that a lower and upper angle are going to be supplementary. So that means they add to 180 degrees. So when I look at angle C and I look at angle D, this is a upper base angle, this is a lower base angle. Together, they should add together to be 180 degrees, giving us the relationship that 100 plus x should be 180 degrees. So x is equal to 80 degrees. Now, that's quite helpful for us because we also know that lower base angles are congruent, giving us that 4z plus 12 should be equal to 80. So solving this two-step equation gives us that z is equal to 17. Both these problems, similar ones, were on the exam and will be on the retake. They're properties that we need to know. Again, it's unique for the isosceles trapezoid that the uppers and lower base angles are congruent. It's different from what we're commonly seeing of opposite angles being congruent. And the mid-segment formula is a popular SOL topic as well. You need to know those particular properties. If you have any further questions, ask me in class. Thank you very much.